Live, loud, in color. Okay. Let's bring up Nat. Welcome to the STEAMulater podcast, episode 1. Let me tell you about proteins. That's what we are calling it. Let me hook up this mic. Okay, here we go. Hello, everybody. I'm STEAMulater, aka DJ Dr. Mook, and welcome to the STEAMulater podcast. Let me tell you about proteins. Episode 1. I'm trying to launch this, y'all. I hope everything works out. We'll see, but I'm trying to launch this and get a way to start talking about my favorite subjects with some of my favorite people. So we're kicking it off today with a special guest. Shout out, Ali, as I bring her onto the stage. Come through. Y'all, I cannot start a podcast without starting with the official best friend, Natalie. Ali, hi.
Hello.
Hi, how are you?
I am doing great on this good old Friday.
You can hear me?
I can. Mm-hmm.
Okay, good. And we can hear you as well. Is that true? I don't think that's true. We cannot hear you. Can we hear you?
Can you hear me now?
I can. I'm supposed to hear you. Oh, Lord. Can they hear you?
Can you hear me now?
Yes, they can. Oh,
Good.
okay. And we got some feedback. So that's good. All right. So we are kicking this off. We just gonna restart it real quickly just because when I edit, I'm gonna have to cut out all of that. Say something that.
Something that. Did you hear me?
Good. All right, that works. We can hear you. All right, so perfect. I don't want to do any more checking or anything. Just work. My gosh, this is all right. Let's go.
Wait, did we start recording yet?
We've been recording this whole time.
Oh, okay.
But it's okay because nobody's watching. I think like Joyce maybe popped in to say hello. Shout out to her.
So we're gonna.
And then we are streaming on everything right now, but nobody's really. Sorry, what you say?
Okay. So we're gonna repeat what we did.
Repeat everything, and then don't worry, I'm gonna chop it up in the end. Oh, we got 8 people watching. All right, great. All right. No, it's good. It's gonna be good. All right, let's get into it. I'm excited. All right. Welcome, everyone. Yes. No, I'm not going to talk about the. Oh, it is 8 people. Oh, because it's on YouTube Public. Oh, that's why. Okay, that's great. Hi, y'all. I love people watching. Shout out. I'm happy I brushed my hair because trying to do this, and it's being done. All right, let's go. Okay. Welcome, everybody. It's your boy STEAMulater, aka DJ Dr. Mook, and I am finally releasing my podcast and recording it officially for the interwebs. Okay. And the podcast is all about my favorite topic in my favorite area, of course, which is proteins. I want to talk to you guys about the intersection of science, technology, engineering, arts, and mathematics. And to me, nothing exemplifies that better than proteins. So let's talk about proteins with some of my favorite people and some of my favorite awesome guests will be coming up on here and we will be chatting. Today, of course, I'm kicking it off with the most special guest, the person who, of course, I would want to kick off this endeavor with. Hello, hello, Ali, my best friend. Shout out to you. Hi.
Hi, friend.
Hi, friend. Tell the folks a little bit about yourself, Ali.
Okay. Well, my name is Allie, and I just love people. I really do. I really love people. I love I don't know, what's the stuff that they would care about? What would people care about?
Yeah, just tell them who you are, what you do, and yeah, like
Yeah.
you said you love people. I can validate that for sure. Yeah.
Yeah, so I love people. I work in an industry where I get a chance to teach people about very important things centered around money and really teaching people how to understand money better so that ultimately they can do better by money and money can do better by them. So I have a background in education and just that's a little bit about me.
Love
Yeah,
that.
that's a little bit about.
That's
Mhm.
perfect. That's perfect. And Ali, you really do love talking to people and making bridges, connecting people with their overall financial goals and overall financial life. But you're also an entrepreneur, a business owner, somebody who works for themselves. And so I really thought you'd be perfect for this podcast. Now, do you have a
Mhm.
good idea of why I brought you on here as a guest?
Well, because we've known each other for over 16 years, and honestly, through our conversations and just like life, actual life outside of what we do, we've also attempted to have several conversations about what it is that you do. And sometimes in those conversations, I think you already assume that I probably wouldn't understand. So you tried to start explaining to me, and then I'd be looking at you like a head and deer in the headlights because of the language. And so then you'd be like, you know what? Never mind. So, no matter, even if I was like, no, no, tell me. And I really didn't understand. So I think you maybe when what you shared with me, like you had this epiphany that you want people to understand better, because one, if we understand better, then like with money, then we can do better by the things that we understand. So I think that's why you have me. You just really guinea pig, but you're trying to see if Allie can get this a little bit, then maybe so maybe this could really be something. So yeah.
I love that. I like, yeah, you're right. You're totally right. And full disclosure, you guys, we have planned this podcast for years and years. Honestly, I've had conversations with Ali over the course of our friendship about starting a podcast. So there's nobody more happier that it's actually finally happening than Ali. And I mean, we've known each other for a long time. Like, how long would you say?
I think it's been I think it's been 16. It's got to be 16. Yeah.
Yeah,
Or
since I came to
13.
the
Was it
country, right?
13?
Like, so I came to America in
When'd you come?
2009, and I met Ali shortly after that at Claflin University. See you.
Yeah, yeah, yeah. So 16, 17. That's right. Years.
We've known each other that long, okay? So all right. So since we have this background, how about you explain in your words? What do you think I do for a living as a protein designer?
Um, I think as a protein designer, um, you design proteins.
Uh huh.
I
Uh huh. You're on the right track.
and and what does that mean? What does you designing proteins mean?
Mm-hmm.
Um, I don't know. You're just always doing a lot of research. I know you do some stuff centered around you have in your past done some things centered around like pharmaceuticals, drugs, like almost like making. making stuff for the use of people getting better, something like that. That's about what I kind of gathered, something like that.
Yeah,
I don't know how
hey,
the design goes in line with that, but yeah. Okay.
you are on the right track. Okay. I feel like
Okay.
this is going to be a recurring question that I ask my guests, be it my friends, and maybe if I can get my parents on here, maybe them. And I feel like the answer you gave is going to be very similar because, yeah, the world really doesn't have a good understanding of protein design. And even if you know a scientist, that you know a protein designer yourself, a lot of people don't know the nitty gritties of what's going on. And it's part of the reason why I wanted to launch this podcast. Because I think this
Mhm.
information is useful not only for you to get to know your friend a little bit more and understand more about my job description, what I went to school for and stuff, but also so that you can apply some of these tools and tricks that we use in this protein design world to your everyday life. And so I'm going to try to relate what I do. I'm going to explain it now. Try to relate what I do to what you do, right, Nat? You're in finance, entrepreneur. You love selling insurance, right?
Mhm.
Right. So if what is the biggest misconception of insurance? Let's start there.
Oh, okay. Meaning like what people think insurance is. Is that
And what
kind
it
of?
actually is not. Yeah, exactly.
Yeah.
Demystify that field for us.
Well, well, the first thing is, I think a lot of people don't really understand what insurance is, and what they believe insurance is just something that the government has come up with that's necessary, because they put a lot of laws around insurance that you have to have it in the event something happens. Like I think most people understand like it's kind of like in the event something happens, then you'll be covered in some kind of way, but they don't really understand, I would say, like because a lot of people kind of see it more in a like a not a negative way, but like in a way of like, oh gosh, okay, I got to get insurance too, you know. And so their perspective causes them to either not have it, not have enough, or get it but be resentful about it.
Mhm.
Whereas if they understood that insurance is nothing more than a transfer of risk, from one person or one party to the next entity, that then they would probably have a different perspective change. So if they understood that whenever you purchase some type of insurance, then what you are doing is you are immediately transferring all the risk that come with that thing to the larger entity that has the ability to take on the problems that could possibly come. So that's kind of what it is, whether it's car, whether it's life, whether it's cell phone insurance, it doesn't matter. If something happens, if you don't have the means to take care of all the risk, then you're just giving that away. So if people change their perspective, they would be a little bit that it would probably serve them better. Hmm.
I love that. I really love that. The de-risking element. When people understand more what they are doing, they are able to better serve themselves, right? So insurance doesn't eliminate the risk, but it makes the risk more visible, right? And it allows
Hmm.
you to go on this financial journey, and not just for your financial journey, but also for your life itself, to be better. Similarly, I would say the protein that I want to talk to you about today does the same thing. While insurance, as you said, doesn't eliminate the risk, right? It makes
Hmm.
transfers the risk onto something else that allows the risk to be more visible and be taken care of in the future. The protein we're talking about today does a similar thing. It's called green fluorescent protein. Have you ever heard of this protein before?
Green for no.
Okay. Okay, because we've been talking about I'm a protein designer, but what is a protein? Like, let's start there. And you just covered somewhere where people have misconceptions for different types of insurance, or misconceptions within the insurance world. There are misconceptions with proteins. When people think of protein, they really think of protein that they eat, right? Or protein powder, or protein
Right.
that they intake. But I'm talking about the molecules, specific protein molecules that our body uses as machines, that plants have machines in, that viruses, bacteria, many different organisms, all organisms rely on proteins as the machines in our biological world or biological universe. And I'm speaking specific molecules. Today, we're focusing on green fluorescent protein. You haven't heard of it? I'm going to tell you a little bit about it. And to help me explain a little, I'm actually going to do a little watch party, okay? We're gonna create a little watch party. So you said you have no frame of reference for green fluorescent protein.
No.
You've never even heard of it.
No.
Based on the name,
Never.
what do you think, on the name alone, what do you think it does?
Green fluorescent protein. It sounds like it's going to be something dealing with the color green. Fluorescent means light, or I think something like light in the protein. So is it a protein that makes something green?
Hey, you're
Light,
not too far off. Let's do
lights
this
up
quick.
something green?
Yeah, let's do this
So what
quick
is
video.
GFP?
Confirm if you can see it for me.
GFP
Okay.
is short for green fluorescent
Uh,
protein. Is
yeah.
GFP. GFP is short for green fluorescent protein, and it's a very big deal. GFP comes from the jellyfish Aquaria victoria, and it's interesting because it's brightly fluorescent green. This means that scientists can stick GFP on the end of another protein and see where that protein goes inside a living cell under the microscope. And because it's quite small at around 27 kilodaltons, sticking it on the end of a much larger protein doesn't really affect protein function that much. GFP is built out of a barrel with 11 beta strands and an alpha helix running down the middle. One of the remarkable things about GFP is that it fluoresces on its own without the need for any additional enzymes. This is because of a motif of 3 important amino acids in the helix running through the center of that beta barrel. Serine 65, tyrosine 66, and glycine 67 are so close together that their chemical groups spontaneously bind together into the GFP chromophore, which is fluorescent whenever there's oxygen around. But what if you want to show what happens to a bunch of different proteins at the same time? You'll need more than one color. And it turns out that mutating key amino acids around this chromophore motif can make subtle changes to the fluorescent color. This way, scientists made yellow and cyan versions of GFP. But what if you need even more colors? Well, scientists discovered another fluorescent protein called DS-red, this time from the coral Discosoma. The problem with DS-red is that it forms a tetramer, and so sticking them on a protein would make those proteins bunch together in groups of 4. But by making a few key mutations, scientists were able to turn DS-red into a monomer called MRFP, for monomeric red fluorescent protein, which was then developed into different colors such as M-orange, M-cherry, and M-plum. So by taking 2 fluorescent proteins from a jellyfish and coral, and a lot of painstaking mutations, scientists have been able to cover the entire color wheel with fluorescent proteins, and by doing so expanded the horizon of biomedical research. Thanks for watching, and if you enjoyed this video, don't forget to like and subscribe.
Okay. So I love that visual explainer because it kind of gives you a good visual idea of what kind of protein we're talking about when we say GFP is, or what kind of molecule when we're talking about when we say GFP is a fluorescent molecule. I think you're already on the money. As you can see, it has something to involve green, right? And light, right? But let's break it down a bit further. In discovery, on drug discovery, or even in the medicine or therapeutic research industry, you have a problem, whether it's cancer or it is heart failure or even fracturing of bones or infection. The problem there is everything is on such a molecular level, microscopic level, that we can't see a lot of what's going on. And then things inside our bodies typically look basically the same color, right? If it's stuff that is, covered by blood, generally all looks red, or maybe some organs might look different shades of red. So how do you visualize a problem that is occurring on a molecular level in a monochromatic gradient? This is the problem that doctors and scientific researchers have had for a really long time before GFP. What GFP allowed scientists to do was essentially now visualize the problem. By sticking this fluorescent protein, you saw the small protein, it's all in its own, this, they call it a beta baryl protein. It in itself naturally fluorescents. It was originally found in jellyfish. So in jellyfish, have you ever seen those movies where jellyfish kind of glow in the dark?
Mm-hmm.
Yes,
Yes.
exactly. And the reason why they go in the dark is because of this protein, green fluorescence protein, GFP. So they took that protein and decided to attach it at the end of different proteins of interest, things that we already know are interesting within the research field, right? And so if you're looking at cancer, a specific kind of cancer, there's a specific protein probably that's being overexpressed that's causing that cancer. Why not attach GFP to that and see where this protein travels to? Is it in the breast tissue? Is it away from the breast tissue? Which part of the breast tissue is it in? Is it in the nipples, the skin, the mammary glands? Where exactly is it localized? Now you can track the different types of proteins because you can visualize it with GFP, right? With the green fluorescence protein. So again, we are making the risk very visual, right? This was the landmark thing that happened with GFP. And in fact, the discovery of GFP led to a Nobel Prize, which is why it's one of those really famous proteins that people like to know. And so what does it actually do? Scientists, like I said, attach GFP to other proteins. And so that when proteins moves, it glows and we can see that. Okay? It's like putting a tracking device on biology, almost like.
Yeah. That's what it sounds like.
But the problem is natural occurring GFP is dim, it's unstable, and it doesn't really work well in human cells. Again, remember, it was gotten from jellyfish and now is utilized in human biology. So sometimes that transfer doesn't work very well. So this is where protein designers come in, right? And say, now can we make this protein more stable, right? Can we make it more sustainable in human cells, so that when we do our research, when scientists are actually at the bench studying molecular mechanisms, they can do this for a long period of time in different cell-based systems that are transferable in the medicine world, right? Can we visualize all of those areas with the same protein GFP? And in order to do that, we needed to know what does GFP look like on a molecular level. We needed to have a snapshot, a picture of this, right? Because we know what it looks like as a substance, right? It's green, it fluoresces green. But the molecule itself, what does it resemble? We have an idea based on that video, right? That he was saying it looks like a beta baryl. How do we know that? We know that because of fields called structural biology, where people, it used to be that PhDs, whole PhDs, people would go to school just to take a picture of a protein. And during this time, this is what happened. People harvested a lot of jellyfishes. They were able to extract this protein, concentrate it down, purify it, separate the protein GFP from all the other proteins in the jellyfish. And then finally, using X-ray crystallography technology, they were able to get an accurate representation of what this molecule looks like. Once we had this molecule, we knew we could make changes, or what is called mutations, in this protein to make it more stable, less dim, so brighter, more visible, right? And then if we can make sure that it works in different organisms and not just in jellyfish, but works even better in humans and even in mice, because mice, remember, is the model system that we do a lot of research, then we can do that. And then other protein designers decided, hey, if we are visualizing this area here that's problematic in green, and we want to see other areas around that problematic area, but we don't want the same problem where everything is now green, right? Changing from everything being red to now everything is green. Why don't we have a spectrum? Why don't we tag these other proteins with blue, and then these other ones with red, these other ones with yellow? And so a lot of protein engineers decided to change, make mutations within this protein to now not just fluorescent green, but fluorescent blue, red, yellow, and it became a whole toolkit, a protein toolkit that people can now use to watch cancer grow, to see neurons fire, to watch infections spread live, before treatment, before failure, before it's too late.
Wow.
Yeah.
That is amazing. So wait, so it all stemmed from the jellyfish, that what was found in the jellyfish. Okay, the whatever was placed in the jellyfish naturally to make it glow, the green one specifically. They took that, and then scientists extracted it, and then the protein designers down the road ended up taking the basis of it and then changing it up a little bit, adding to, taking away certain things to make it be able to be useful for medicine.
Exactly. To make, and remember, so it doesn't solve problems. GFP didn't solve problems, right?
It
But it
made it
just made,
easier to identify.
exactly, it made the problems visible, making it easier for us to identify the problems. Because visibility
And,
changes everything in biology, in business, and indeed
but
in
but
our
but but
conversations, right?
if you make it easier to identify the problem, then by nature, or whatever that word is I'm looking for, you make it easier to solve the problem.
Exactly. If you're able to identify the problem quicker, if it's more visible, then yeah, it makes it easier to solve. Because solving something that you can't see or something that you can't that is not visible is really hard, right?
Right. Wow. Wow, that's a very important role.
Thank you. That's the protein design field. That's an example of it, and
Oh.
I'm using protein hopefully to make it more concrete. Does your understanding of my job, is that more like, do you think it's more concrete now?
Yeah. Because if I had to summarize it, I would say you guys take you take something, maybe proteins in this way. You take proteins and you design them to make the protein better, more efficient, more effective for whatever task is in front
Exactly.
of you. And without you, everything would just stay the same. Things wouldn't seriously, like medicine wouldn't progress. Leave everyday life, wouldn't progress. Building materials, like my dad, he's a contractor. So now, there was a time when people only built from wood. Now they have designed all kind of materials that don't use wood, that build buildings and homes and, things like that. So I'm assuming, do you think protein designers had something to do with that
With construction?
coming up? Not the construction, but the materials and the materials that are used to be able to be used for the construction or the building. You see what I'm saying? Now
Yes,
they
yes.
have
No, I like how you're thinking about it, because protein design isn't just in the medicines world. It touches every industry. It touches, for instance, material science, which is where a lot of polymers are thought of being made, and proteins
yes,
are a type of polymers. So there are
yes,
people in this world who are trying to engineer proteins that could be used in chips, in circuits, as
yes.
fibers in our food, as nutrition, as fibers for
Right.
clothing. I had a student during our STEAMulater games who was very interested in making silk, like a protein, designing her own silk protein, as
Mm.
opposed to the way we harvest silk from worms and silkworms and stuff like that. So yeah, there
Mm.
is a whole industry or a whole plethora of things that different types of protein designers can contribute to. And sometimes it's not always about fixing things or solving things. Sometimes it's about finally seeing the problem, just like we saw with GFP today.
Wow. Okay. Makes sense. Makes sense. Wow. Very important. Wow.
And
We
so
should have
protein
taught us that
design
in
is so
school.
important,
Wait a
so
minute.
much so that last year, or the year before last, 2024, half of the half of the Nobel Prize award in chemistry went to protein design, and it went to my advisor, my PhD advisor.
Mm,
Shout out to David Baker.
David, I know about him. I
Yeah,
know
my
about
friend knows
him.
about him.
Yes, I know about him.
Yeah. And so I'm hoping I get a chance to explain this to more and more people. Starting today with, of course, you, Nat, and I feel like you came away with a better understanding. Do you think Yeah, let me get some advice from you. How do you think I could better improve these conversations moving forward? Who do you think would be a good next guest to have? And yeah, what was your biggest takeaway from this kind of conversation?
Oh my goodness. Well, one, first of all, get to understand you better as my friend in the field. But two, like, this is very important. Like science, science is everything and everywhere. But it is the thing that applies to everything, but it is the thing that most people least understand. And so I don't know what that's about because they give us a curriculum, especially if you're in public schools. But somehow I feel as if so much get because it's because of, into some way like science can be very big. Sometimes it might be a lot for our human brains to conceptualize, so we block it out or we get defeated. We say, oh, this isn't for me or it doesn't apply to me, especially when we're like younger people. So we miss a lot of the fundamental building blocks. So then we grow up and we just are kind of always seeing science as a foreign language. It's alien to us. So with that being said, we don't if we don't understand the thing that's probably applies to us the most, then we're just kind of letting life happen to us versus happening to life. And so I think this conversation, which I'm really grateful for, I'm very happy for, um, it has enlightened me just first and foremost on, the idea of proteins, because I learned a lot about the green fluorescent, was it green fluorescent protein, something like that, right? I learned a lot about that. The GL, the GSP, the GFP. But I learned a lot about that. Um, but just kind of you giving me a basis, like a basis of understanding. This is very broad. So I actually, me personally, I would like to have more conversations so I could get further in depth. But what I think other people will, bring like from this, or maybe the type of people you should talk to. Truthfully, I think you should talk to the people that don't have a clue as to the first thing about science, the language of science, you know, um, like all of this different whatever we don't because if you can take someone from 0 and you can take them to elevate them to 20 or 0 to 50 or 0 to 100, that is the true, I would say that is the true marker of whether this type of conversation is effective and important. You
Yeah.
know what I mean?
No,
And
I
and
agree with you
so
completely. This is part of the thing
yeah.
that excites me the most in the future. Like, of course, I started STEAMulater to try to communicate science in a really culturally inclusive way, in a way
Hmm.
that meets people where they're at, but also to teach about the different tools that are in science that could be used in multiple different industries. Because
Hmm.
communities who do not have scientific tools suffer overall from their problems never being addressed. Probably
Hmm.
if communities like in Flint had scientists, maybe the Flint water crisis would not be still raging on, right? And so there's an overall
Right.
reason for science, communication. Hi, I see you, Layla. Shout out to you. But what really excites me is what you just said right now is when people do get it, when people start getting these different nuances and things that go on in the science field on a really basic understanding that applies to them in their life. What
Hmm.
is the new thing, innovative thing that they could do with those tools, with that information, that knowledge? When people like
Yeah.
you who are outside of science start thinking, oh, could I design a protein? And if I designed a
Right.
protein, what would it be for? What area, what problem would I be trying to solve? That is
Exactly.
extremely exciting to me because
Yes.
science, as you said, touches everything. Our world is
Yes.
running on steam right now. One of the very, simple things, and we've talked about this before, is people are doing all of this investment strategies, all of these putting their money in different companies and these new startups or areas in biotech in particular, trying to predict the market, trying to hedge their bets. And a lot of people don't have a clue about what these biotech companies are actually making. What are the molecules that they're
Hmm.
doing? What do the molecules do ultimately? Like particularly drug discovery biotech companies, they're all hinged around the
Hmm.
molecule. I'm not a financial
Hmm.
advisor, but if I can shine a light and say, hey, this is the signature landmark molecule for this specific biotech company, and this is what it does. Understand it a bit more. Maybe it will shine a light in people within our community on how they invest their monies and how they move around the world. Imagine if we had gotten into Ozempic before Ozempic was
Right.
super popular, right?
Yes. But people, I mean, I hate to say it like this, people perish because of their lack of knowledge, but the perishing isn't like literally death all the time. Sometimes it's you just you never get the chance to live because you don't know. If you don't know, how do you get a chance to really be the best version of your human existence? We get about 100 and something years. But the difference between the people that have the knowledge about a lot of things and the people that don't, it's a big difference in the life and the lifestyle. So I think yeah, I not that I think I really know, like, this was very enlightening. We need to do this some more. We need to keep talking some more. You need to keep teaching me, because as you were talking, I'm thinking about people like me, that have a voice or a platform or just whatever within myself. Like, if I had this kind of information, like the greats, and I'm not calling myself necessarily one of the greats, but I'm saying if the greats had this kind of information, think about how much further along, the world would be, because they would be spreading it. And the only reason they don't have it is, why? Because they didn't get it. They missed it. Somewhere along the way, it was missed. People like you picked it up, thank God, but it's not enough people like you who look like you, to be able to help people that also look like you to understand. So I'm just excited. That's good. That's good stuff, man. I'm curious. So I'm very interested in who your next guest is going to be and what that conversation is going to look like, and I'm going to be in tune.
Okay, I appreciate that. Okay, and I mean, Natalie, you hit the nail on the head right there. You talk about you ain't one of the. You are definitely one of the greats. What are you talking about?
I'm coming along. I'm working on it.
I really appreciate you for even coming on this journey with me. Honestly, like, we've been talking about this for a while, and you've been my sounding board. You're the one that I keep on crying to, helping me bring it to life. And thank you so much for even trusting me to go on this journey. I know, just even downloading this app, chat,
Okay, Martin, what I'm supposed to do? Okay.
You say what?
I was like, okay, Martin, what am I supposed to do? Okay, I guess I'll download Fanbase. All right.
You're like, what is Fanbase? Let me go ahead and
Fanbase? And here I am, changing my life by learning these fundamental building blocks that now I can take and go further on. So yeah, I got you.
Yeah, hopefully we do another conversation of this. I really enjoy talking to you. I really enjoy, doing this kind of stuff, which is why I wanted you in this premiere pilot episode to figure this out. But I definitely want you to come back, because the next question is going to be, now with all of this knowledge, Natalie, what are you doing with protein design knowledge? Okay.
Exactly. Oh, I'm excited to think about it. Mm-hmm.
All right. Well, thank you so much for coming on, and thank y'all for watching. If you're watching this on the replay, or you are watching the reels that are associated with this, or TikToks, wherever you're watching me at STEAMulater, I am everywhere. Thank you for tuning in. You have so many options, but you tuned in right here, so I appreciate that. And as always, I won't see you later. I will
see you later.